I believe you can see my screen. Please, if you can't see my screen, just let me know.
Yeah, we can see your
All
screen
right.
clearly, sir.
All right. So this, should I call it presentation, um, is targeted at securing at least yourself as a beginner, uh, so that you can avoid potential hacks and be able to identify them before you get a victim of that. So to get started, this is just how we're going to look at the whole topic. What's exactly a smart contract? Why is security important to you as a developer, as a user of Web3 product, interacting with smart contract? So, what are the common smart contract risks? We're going to see how to check for from common smart contract risk and look at the tools and techniques that we can use to do some basic analysis on smart contract, and then we'll just go through a very realistic scenario of how one could fall victim to a very common yet sophisticated uh, attack as a user, and what are the common best practices while interacting with a smart contract. So, what are smart contracts? So, smart contracts are basically code that execute themselves and are deployed on the blockchain. So, basically, you just think of it as a set of rules that would always be followed when when the conditions that are required to trigger it are met. So, basically, those conditions can't be changed once they are executed, and the results cannot be rolled back. So smart contracts are also transparent by nature. Everything that happens on the smart contract is visible on the blockchain. That least that is the barest minimum. Um, to some extent, you can even see the code of the smart contract and you can read it. Uh, s- Most smart contracts are immutable. However, some smart contracts are designed in such a way that they can be upgraded. So it's no longer a defining feature of smart contract. So, but basically, that's basically what smart contracts are. They're just code that get executed once the conditions that are set are met. So once condition A is met, B will be carried out, and result C will be seen by the user or by whoever triggered the transaction. So we won't dive into how smart contracts get executed or how smart contract transactions are constructed. No, I assume that you know how to use a wallet and you've used the wallet to hold at least one digital currency, and you are thinking of how to safeguard yourself as you interact more with smart contract as a user. So moving on from basically what smart contract is, we'll look at why smart contract security is important. So over the past decade, over 5 billion US dollars have been lost to different forms of hack. Some of them are very big. They attack protocols, but the most of them attack individuals. So even if you are lucky, you heard about a hack, it was affecting some protocol, and they stole funds from that protocol, and your funds are not included. It does not mean that you are safe. It just means that you are lucky. So, for your own safety and to prevent your own loss, it is important to remember how to go across securing yourself and finding potential faults in the smart contract that you're about to interact with. So personal protection, and so that you don't become statistics. And security is very important in Web3. So what are the common smart contract risks that we can come across? So the commonest smart contract risk that target users deliberately is access control issues. So we have different forms that it can take. We could have a situation where uh, the protocol does not define properly how roles are assigned, and a regular user can become a super user and get admin access to how a smart contract can work. In the user level, it may not target the smart contract, it could target the user themselves, maliciously crafting transactions and using sophisticated user interface that make resemblance to genuine protocol user interface, and make users to give them inappropriate allowances to spend from their wallet. Another another form of access control issue is malicious permit. We're going to look at it in our hands-on um, demonstration. So this access control issues is the most common for the target users. Is the most common and it is the most successful. So if you are likely going to get hacked, it will either be because you unknowingly gave a protocol or a malicious contract permission to spend from your account, and basically it wipes out your balance, or you merely you gave permit to a smart contract and it basically wipe out your balance to zero. So these are very common and they're very successful. They don't work independently. They usually work in association with very sophisticated social engineering where they mimic genuine protocol, and they can do that to a very large extent, even making themselves look very genuine that you may not be able to detect that they're actually not genuine. However, if we follow the best practices, hopefully we'll be able to detect most of them, and we can be able to sense almost all of them before we uh, sign or give permission to those kind of contracts. Another form of risk of smart contract is MEV attacks. So because smart contracts are transparent, what you want to do can be known even before you do it, and someone can take advantage of your action and benefit from the protocol either at your own risk or not. But most of the time, it's at your own risk. So MEV attacks is something that you should be at the back of your mind, especially when you are taking actions on the blockchain that is of high economic value. For example, if you're moving or you're trading uh, on an account, and that account has traded up to $1,000 US, it is enough for MEV bots to begin to monitor your address, and if they notice profitable actions that you're about to take, they can go ahead of you and take the profit, and then you will come out from the trade with lesser funds. Another attack format for smart contract is governance attack. This is not direct attack to users. However, it can be considered a direct attack to users where the users form the DAO that is being attacked. So if the user is part of a DAO and he contributes some fund to that DAO, someone can uh, enact a governance proposal, and if he has enough economic power, he can push that proposal to go in his own direction, and that proposal might be detrimental to the user. Maybe it's gonna drain the whole treasury or something of that nature. So if you are joining a DAO, check how secure the DAO is to governance attack before you contribute a dime to it. And if the DAO is not secure enough, it's better you put your funds in somewhere else that you can make better money from than to put it in a DAO that you have a high chance of losing it. So other attacks is liquidity attack. I've done this myself, but it was not for malicious intentions. So just for testing purposes. It's a situation where you just basically take out all the liquidity in the market, and you make profit from the spread. Basically, that's it. You just burn all the tokens and take it out from the market, and all those who have given out their hard-earned valuable tokens will be left with your shitcoin, and you go home with their dollars. So it's an attack that can be done and it's very cheap to do. So if you see a new token, please don't just ape in. If you don't have a good reason to ape in, and even if you have good reason to ape in, just put it at the back of your mind that so long as the liquidity pool tokens are not burned, you could get burned. Pun intended. So other forms of attack is external dependencies like flash loan attack and oracle manipulation. Oracle manipulation, it may not affect you directly, but it can affect the protocol that you have your money in, and you lose your money. So if you are interacting with a protocol, lending protocol, a decentralized exchange, and you see that they depend on an oracle, please just try check how does the oracle secure itself against manipulation, either from any source, whether collision or individual or participant in the oracle network trying to manipulate results. Because if the oracle can be manipulated, basically your funds are at risk. So you can check put an eye for that when you're interacting with a smart contract. Flash loan attacks are becoming less common because now they're becoming a lot more expensive to do. However, it can be very profitable if you find an arbitrage opportunity, and that arbitrary opportunity can be at the detriment of the users, just like MEV, but and the benefit of the attacker. So you can choose to learn any of this attack and try to see how it works practically if you are interested in that, and you can see how to practically prevent yourself from falling victim to it. Most of the time, you likely won't know that you've been successfully hacked until much later. So it's important to be proactive so that you either pick them before they happen to you or get out before it bites you. So other forms of issues that contracts could have is implementation bugs. These ones are likely not going to be caught by you and likely will be caught by professional security researchers and security companies. And that's where you can look at their audit report summary at least or executive summary at the least to kind of like have an idea of what issues the creators of a particular protocol have deliberately left inside, even though they have been audited, and what were the issues they found out when they audited the contract, so that you can actually confirm that those issues are no longer present if you really want to check. So, what are the tools for and techniques for analysis? So, I will try to stay lean on this, and we'll just look at the common ones that you should familiarize yourself with. So, GitHub is very important because that's where most developers host their code, and you can go and see all the code in a very friendly manner, or at least a more friendly manner, that you can even download the code on your own computer. I do not recommend, and go through the code and even run the code if you are that brave. So, apart from GitHub, where you can see the code, you can also check out the chain explorer in particular that you're interested in. So if you're interested in Ethereum, you can check Etherscan, its derivative for EVM chains. If you're interested in Polkadot, you can check Polkascan, Mint Scan for Cosmos, or SolScan for Solana, depending on the chain that you are interested in. So what will you be checking when you go to these chain explorers? Basically, for chains like EVM that provide a lot of information about smart contracts and transactions, you can uh, look at all the functions that are exposed by the smart contract. That will give you an idea to give you an idea of how that smart contract can be interacted with, and give you an idea of what functions are useful to you, and then you can check out those functions in the GitHub code that you might have been going through before. Apart from that, you can also explore transactions. So, why testing out an application or a protocol? You can go to the chain explorer to see exactly the contract that are invoked and confirm and be double sure that it's what you want to happen that actually happened. So other tools that you could use, which is out of the scope of this presentation, is static analysis tools like Securify, and uh, you can use dynamic analysis tools like Ecnida or Echidna, or and you can of course use AI. And I will show you how to use AI to check for potential issues with a smart contract. So what are the techniques? So even if you don't have GitHub account or you don't want to go to GitHub, you can just search about the project. Just a basic website can go a long way in telling you whether this project is scammy or not. Just search project A plus is a scam. That's enough. That's enough for you to know if this project has been involved in at least one reported scam and how the scam was. So if the scam is something that it seems like they are playing the same script for you, then you can be aware and you know how to go about that. If you are, it's just to abandon that or to play it out and see how it actually ends. So you can just search for the project and just say it's a scam, and you see reports if it's a scam or not. If you still don't get enough results, you can check um, different hubs that likes complaining, like Discord. They like complaining there, so you can add this. You can add, sorry, you can add Discord, you can add Reddit, and then you can see if there's any specific group of guys that being that be hurt by that project or that protocol, how they did it, and then you can prevent yourself from being another statistics. AI security analysis is also an important and simple way to check if smart contract is having potential issues. So once you check the chain explorer, you see the functions that are available, and you go to the GitHub and you check for those functions. You can copy the entire function and paste it in ChatGPT, Copilot, Grok, Cloud, or any general purpose AI chatbot, and they can draw some insight from the code. And even though not everything they tell you is a real vulnerability, they can kind of like keep you aware of some of the nuances of that smart contract so that you know what happens when things happen. So it's a very simple way to go about checking the smart contract for potential issues. If you also have the skills, you can do some static analysis, some dynamic analysis, formal verification, and basically just read through the code one by one to see if there's any issue. But this will require you that you already have some background experience and skills. So let's go into hands-on analysis of a smart contract. So if you want to follow along, just go to this website. Uh, Go to github.com/cen. Uh, then you go to Honey Drip. So let's see if I can put that. I can put that in the chat, or I'll just assume that you guys go there and then I'll put it in the chat after I'm done. So you can go through it after the class. So I've already opened the UI. So let me just copy it here and send it. All right. So if you want to follow along, you can follow along. So if you go to the website, you will see this. You have a contract and the UI, and you have a README. So there's a warning that this contract is malicious, is deliberately malicious, and should not be used. If you want to use it, please use it only for educational purposes. So what is the app about? The The app is a deceptive app that uses permit feature of Ethereum to get um, allowance to users balance and allow the smart contract to wipe out the user's balance. So this is a very common approach that can be used. This is a very common approach that can be used. Let me see if I. mm, So no. So this is a very common. It's a very common uh, approach that is being used. Basically, the malicious developer creates a UI that says it's a yield aggregator or yield optimizer or yield farming, something that promises the user some money in return. Everybody likes to make money, and that's why we're all trying to make way in the Web3 space. So they put it in your face that you can make more money here than probably anywhere else, and it's basically simple and easy. Just give us the money, and then we'll multiply it for you. And then some of them will even go ahead to give you a very detailed lie, a very detailed lie of how they actually work. And it might sound true, it might sound real, it might sound logical. Well, all they need is just for you to just give them permission once, and that's all. So let's assume that we come to this contract, we have no idea of how this contract works. We just want to check if it's a genuine contract or not, and we don't have all this warning and good readme to use. Some contract don't even bother to do that. It's very they're fast to deploy. So you go to the contract and you are lucky it's a Solidity contract. Most AI know how to use Solidity. You are confused. Where do I go to? How do I check? You can just go to this contract folder and you enter there and you see all the contracts that are used in the project. So we only have two smart contracts, mock ERC20 smart contract and malicious.sol. So when we enter malicious.sol, we have a lot of documentation and a lot of description of how things work, but we don't have the energy to look everything. We don't have the skills to read and understand. What can we do? Basically, just copy everything, or copy whatever you need. So this is a lot of code. Some programs can be much longer than this. Others can be much shorter. So if we go to something like cloud and we just say create a new chat, and we just say do a detailed security analysis of this code, be comprehensive, deep, and broad. Ensure you cover everything. So let's give it more context. So let's say assume you are an elite blockchain slash web security researcher and auditor. And I'll tell you what to do for us. So now we just paste the code. I hope everything enters. So we're lucky everything enters here for cloud. So we just ask cloud and then we'll see what it tells us. So you just wait a couple of seconds usually, and you see what the AI has to tell us. So if we can just start reading before all the result comes out, we'll notice that it already started giving us some information. It's a critical security assessment. It said this is an intentionally malicious contract designed for educational purpose that demonstrates sophisticated social engineering attack using EIP 2612 permit. The contract should never deploy on mainnet. Basically, what we started with. So these are the critical vulnerabilities. There's a direct theft of fund via permit processing. So the issue: smart contract immediately transfer tokens after processing permit, essentially stealing them under the guise of gas optimization. So this is how we can start picking up on vulnerabilities. Another vulnerability, say critical VIP program token migration to admin issue. The VIP program directly transfer user tokens to admin address after permit execution. Another one, critical emergency evacuation drains all funds. So it's not very complicated. Once the malicious developer set this thing to run, it will automatically run. And once it runs, for you to recover your funds. There's absolutely no way, unless the attacker moves that fund to a centralized platform, there's zero way for you to get back your fund. They can block the fund, everybody loses, but you won't get your money. Another part that it shows us is the advanced engineering tactics that were used. It presents batch commit as gas optimization. In reality, it gains approval for multiple tokens in a single signature. So it doesn't have to prompt you to give it approval more than once. Just one single approval. It's enough for it to get approval for up to 10 tokens, and it should wipe them out. VIP program exploitation, say exclusive access requiring multiple tokens. This one even makes it more realistic. So I think that you're providing more permit, but it's just getting more and more access to your wallet so that it can steal more from you. And it also uses a trick, fear of missing out, an exclusive drive to encourage you to give them your signature. So another way that I use is this fake high APY promises. It is not very high compared to what some of them will promise you. This is just 28%. It's realistic, but it's still a scam. It's still fake. Some of them can promise you up to 100%, up to 250%. It's all scam. But it doesn't mean that because the promise is so is this amount, that means it's a scam. No, it's because of what was implemented in the code. That's why it's a scam. You know, some genuine protocol actually provided and still provide API this high, but it does not mean that all protocols that provide high API are scam. So it also creates some sense of urgency for you to okay, you have to do this sharp so that you can get your point instead of missing out on the high API. So more attack vectors, telling us how this was used to actually gain access from user, how we batch permit up to 20 permits for a single batch, how we harvest all the user funds, how we ensure that we have full admin control. This is a red flag. Anytime you see admin control without any plans to cancel that admin control or upgrade control or any of those kind of stuff, it's a red flag. And if that project is more than a year old, I will be very skeptical putting my funds in that kind of protocol. Role-based pre-date escalation. So even though it not starts with an admin that can wipe out your phone, you can still transfer the admin to a different. So it means that even if you are able to identify the hacker's address, it does not mean that the contract is useless for him. He can still change his admin address and get more funds from that account without that account getting blocked. So it's something that can be automated, so it doesn't have to even be manually done. I'm telling you all this so that you know that it is very easy to really hack people if you want something that is beneficial to both yourself and to others instead of trying to hack people, unless you want to do it for just learning purposes. So other issues that are in the code, improper nonce management. Now this one is bugs in the code, inconsistent migration tracking, unbounded array growth, economic attack vectors. You can manipulate the reward, fee extraction. So all these are issues that the code has. TVL can be manipulated. We also have reactancy and MEV risk. So these are how you can just go through it. So audit claim. It also claims that it has audit from static. So this thing you see audited by company A or company B, don't believe it until you go to the company A site and you actually see it on their GitHub that they audited this program and this was the issue they found, and only that should you believe. If you see it on the people that were audited, don't believe it because it can be a lie. Anyone can just type anything they want and send it out. And then there's a lot of technical jargons to confuse new users. So they see a lot of APY, this, permit that, and high return on investment, yield optimization that you have no idea how it works. All you just know that it gets more money for you. So these are just this is a way that you can go through a smart contract, and you can see other issues, compliance and legal risk, misleading investment promises. Even though all these are crimes, it's difficult to find who is behind the code. All it needs now for me is just to build some reputation, just to get, even if it's just 100 victims, I am satisfied. 100 victims with $100, that's $10,000. I am more than satisfied that I'm getting $10,000 from just less than a day work of coding. You know, that's something that most people will not even get for a whole year. And if you can just get 100 victims and each of them putting $100, that's enough. That's great. You know, but it's something that at the end of the day you do something like this and you can't sleep at night because you are scared. So all this is just so that you protect yourself, not so that you can harm others, just so that you can protect yourself and warn others. So you can go through and then you can see everything. So it gives us a detailed breakdown of the code. We don't have to read everything ourselves. Now we can pick what we want to read. We can go through it and say, okay, it steals users fund. Where does it steal user fund? So one of our critical vulnerabilities is direct token theft via this. And then we check here. What's the process? Okay, it gives us this side. So we can just take this comment and we'll just search it in the code and we may find it. So this is one we are looking for. So process batch permit. So we can look at how it was done. So this is how it was done. Basically, uh, we take the batch permit that the user has maliciously been allowed to give, and we just go through each of the signature. And as we're going through each of the signature, we are just transferring all the money out. And basically, at the end of the day, we still emit fake events, so that even if you check the chain explorer, you will not see that we transferred the money unless you check the transfers of the of the transaction events. So it can be very interesting, and it can be very sophisticated. So that if you don't pay attention enough, you can just think it's a normal transaction, and you check your chain explorer, you see, okay, successfully transferred 20 tokens to this contract. But if you not check deeply, you will notice that the contract itself was moving all the funds out to a different address. So this is a wrap up for the hands-on. So let's go back and see some of the best practices that we can follow and see that we don't fall victim to this kind of hack and even other kind of hacks. So number one is to verify contract audits. Do not believe projects that say they've been audited. Do not believe them. The only way to verify is to go to the page or the repo or the GitHub profile of the company that they claim audited them, and you check and see among all the projects that they've audited, does it include them? One, did the time that they say they were audited, does it align with what the company said they when they were audited? Because a project can be audited 2 years ago and they've released more than two different iterations of their protocol, and they can still claim that that company audited them. Meanwhile, their current code was not audited by that company. So you have to still verify that it was actually audited when it was said to be audited. Then you can use AI to review the code. It is straightforward, as you can see. And then you can go online and check communities like Reddit and see how people complain or how people talk about the project being a scam. or how the developer of the project is not reliable or has a bad reputation for doing scams in the past. Then you can test with small amounts. So if you have a new yield optimizer that you think is doing well, you want to try out some money, you can just try out with small funds, depending on what you can afford to lose. Please, only what you can afford to lose. This one is not trading. This is like you want to actually use an application, so you want to try out with a small fund that you okay. If it goes well, then you can add more and then use it. Since you're trying something that has a near zero risk if everything was genuine. So after that, you can try to understand the smart contract functionality. This will require you to learn about smart contract as a developer. Then you can stay informed on new exploit. The benefit of staying informed on new exploit is not just so that you know when they happen, it's so that you can be able to check that you are not part of those that are vulnerable to that exploit, and you can protect yourself if that exploit can be also done against you. So what I can say just to wrap things up is that the people that are most targeted for hacks and problems like this are the most active people in Web3. So if you get more engaged in Web3, you start getting roles. Just be prepared that you'll be attacked. There's no way around it. You'll be attacked, and the only way you can prevent those attacks from leading to fruition for the part of the hackers is to protect yourself at all times and be very skeptical of anything that you're interacting with. Be very, very skeptical. So thank you very much for your time. I'll be willing to take questions now.
Wow, that was really an amazing session. Thank you very much, Dr. Chinedu, for that great one. I'm sure we all we've been able to learn and really learn about smart contracts and all that. Please, if you have your question, kindly drop it in the chat, or if you wish to speak, you can as well raise up your hand. Please, if you have a question, kindly indicate by just raising up your hand or sending your message in the chat. Thank you. Okay, I think Hamza, do you have a question?
Yeah, 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 yeah.
All right.
Sorry, good evening.
Good evening, Hamza.
Yeah. I wanted to ask if this same method that he uses to track this smart contract and this thing and can be used in doing crypto on-chain crypto analysis, maybe using AI.